Welcome back to my channel. This is your host, and today we're going to be answering the question, what if Uranus had rings? Because you know what? Our observations of Uranus are pretty incomplete, and our understanding of its rings are too. So why not explore a few fun possibilities based on what we do know about this sideways planet? Let's get started. Uranus is unique in the solar system because it rotates almost perfectly on its side. We don't know exactly why this happened, but we think that something big has crashed into it in the past. If this thing that hit Uranus was a protoplanet or a large comet, it would have stripped away much of Uranus's atmosphere and left behind rings of ice and rock. And that's exactly what we see today. But scientists think these rings are intermediate in complexity, meaning they formed from an event like a giant impact, but they haven't had enough time to fully evolve yet. They are intermediate in their complexity. So what would the rings of Uranus look like if they were more complex? There are so many possible answers to this question, so let's try some fun scenarios. The most popular theory for how Uranus's rings formed involves a lost moon. Some moons orbit planets like jewels in a crown. Think about Jupiter's moon Europa or Saturn's moon Titan. These moons are so large that astronomers call them planetary moons. Meanwhile, Uranus only has one known planetary moon, and that's Miranda. It's small, irregular-shaped, and highly cratered. Scientists believe that Uranus may have had several planetary moons in the past, but something caused them to crash into each other or into Uranus itself. So what if instead of crashing into the planet, they formed rings around it? In 2014, researchers used computer simulations to investigate this scenario. In their simulation, a large protoplanet struck by a smaller moonlet. Instead of crashing into the planet, the moonlet formed a thin, dark ring at the equator. Over time, this ring became thicker and more opaque. But after a few billion years, the gravitational interactions between the particles in the ring caused them to migrate inward until they settled into a thick, opaque band near the planet's equator. This could explain the main rings that we see today, except that we know that Uranus's rings aren't opaque. You can actually see through them. So maybe there needs to be another process that thins them out again. After doing some tests, scientists found that if the particles in the ring were less than 1 meter wide, then the ring would remain transparent. And this makes sense because the smaller the particles are, the less gravity affects them. And if they're far enough apart, then they won't interact with each other. So this model seems to work well with what we see around Uranus. However, we still don't know what caused this impact event. Maybe it was a rogue asteroid or a large comet. And it also doesn't explain the intermediate complexity of the rings. For instance, computer simulations show that all the rings should be opaque, but that's clearly not the case. So astronomers are still looking for other potential causes of Uranus's rings. And one very unlikely cause is a shattered planet. You heard that right? A planet made entirely of diamond could have been ripped apart by tidal forces when it got too close to Uranus and then reformed as rings. Okay, I'm just kidding. Kind of. Astronomers did propose this idea in 2018. And before you roll your eyes, hear me out. This could explain the unusual properties of Uranus's rings and the presence of diamonds on Earth. Our solar system formed from a giant rotating cloud of gas and dust called a solar nebula. As the cloud collapsed, it spun faster and flattened into a disk. Gravity pulled material from the disk up and down, forming protoplanetary clumps. And over time, these clumps became the planets we know today. This process should have happened in Uranus's system too. But instead of becoming spherical, Uranus ended up almost completely flat. That's a weird anomaly that scientists can't explain. But here's where things get wacky. If the solar nebula had a strong enough magnetic field, then tidal forces could have stretched one of the protoplanets long and thin like a hot dog. It would have been so massive that even though it was elongated, it would still be the densest object in the system. And this dense planet would have been made mostly of pure carbon, which is typically only found in diamonds. So one possibility is that Uranus's rings are the remains of this giant diamond planet. But of course, this is a very speculative idea. The magnetic field in our solar nebula probably wasn't strong enough to cause such a drastic shape change. Also, this doesn't really explain Uranus's tilt, so it's still just a fun idea to consider. Okay, so what else can we imagine? How about a shell of eggs? I mean egg rings. Researchers explored this idea in 2021. When objects in space collide, they usually shatter into small fragments. So if a large body hit Uranus, it wouldn't form a ring. It would form lots of pieces. But what if the body was made of something special? Like an extremely strong material that keeps its shape during a collision? Would it form a ring? To answer this question, researchers turned to physics. They analyzed the collision of a rigid sphere with a liquid half-sphere. The rigid sphere represents a large comet or protoplanet, and the liquid half-sphere represents Uranus. By changing the physical properties of the comet and the planet, the researchers ran thousands of simulations, and they found one parameter that resulted in rings instead of chunks. If the liquid half-sphere is weak enough and the rigid sphere is both strong and fast enough, then the liquid will flow around the rigid sphere like water flowing around a rock in a river. But if the rigid sphere is even slightly more massive than the liquid half-sphere, then instead of orbiting around Uranus, it will strip away a layer and leave behind a ring. So if a giant comet or protoplanet made of some super strong stuff like rock or ice hit Uranus, it could remove a chunk of the planet and form a ring. But unfortunately, this model falls apart when you consider the intermediate complexity of Uranus's rings. Chunks would either be ejected from the system or they would clump together and reform into a single moon. So if this scenario did occur, something must have cleared away the chunks and left behind only a thin, complex ring. Perhaps over billions of years, particles in the rings eroded away at the surface of any small chunks, leaving only larger bodies. Or maybe some of the chunks migrated inward due to gravitational interactions and crashed into Uranus itself. Either way, this egg ring hypothesis is an intriguing possibility. These are just a few of the many theories for how Uranus's rings formed, and none of them are complete. All of them have some pros and cons, and all of them leave us with more questions than answers. The good news is that we should be able to answer these questions soon. NASA's launching a mission called the Dragonfly, which will fly through Uranus's rings and perform the first ever atmospheric probe of this sideways planet. The Dragonfly spacecraft won't reach Uranus until the 2030s. But when it does, it will be carrying instruments to measure the chemical properties of the rings. It will also be equipped with a camera to take high-resolution photos. And finally, it will carry a spectrometer to analyze the atmospheric composition of Uranus. And although we won't be seeing any ringside views of Uranus, Dragonfly's investigation of its rings will be groundbreaking. And who knows, maybe we'll even find evidence of diamond planets. I love science. It's so cool. Thank you for watching this episode. If you liked it, please subscribe. We have more videos like this one on our channel. And if you want to help us make more videos like this one, then you can go to our support page. There's a link in the description below. All the best. See you next time.